Welcome to video 3 in a series of introductory videos for InventorCAM. This video's topic is starting a new milling project. So in this video, we're going to cover milling projects, but some of the stuff you'll see here is similar to what you'll see in turning. So first thing you do is you open up your model in Inventor, and then we'll go to InventorCAM. We'll click New, and you can see you have access to the modules that come with the software based off your license. So if you're going to program for a mill, you choose milling. If you're going to program for a lathe, you could choose turning or mill turn. The reason being is because in mill turn, you actually get the full functionality of the software. So it's actually the one we recommend that you select, and you actually have access to it regardless of the fact that you bought only a turning license. For this one, we'll do milling. So I click on New Milling. And in this first window, you'll see the different definitions for this part file. In this case, we're going to create a separate InventorCAM only file. So all our tool definitions, tool paths, everything we're going to do in this part file is actually going to be in a separate InventorCAM file. So we need to give it a name. So in this case, you'll see that the name is actually similar to the name of the Inventor file. It got modified because I've already done this file before. This is a copy of it, so that's why I gave it the -1 by default. But normally, it would just take the name of the original file. Since this will be a separate file, it's asking me where I want to save it. So this address right here is where it'll be saved, and that is because I checked this box here to save it in the same location as the original Inventor file. If I uncheck this box, you'll see the address is now the default address we saw in video 1 of this series. So wherever you need to save it, and you can see that it also knocked off the one there because in that folder, I don't actually have an InventorCAM file. So it checks the folder, see if there's one already there, and modifies the name. If not, it'll just take the same name as the Inventor file. And you either use the default address from the user-defined directories, like we saw in video 1, or you save it side by side with the original model. Where the original model is being kept is this address right here. And like we mentioned in video 1, in the default settings, I told it to open up this part file in inch. But say this one particular file, I need to work in metric. I have the ability for this one part file only to switch between inch and metric. So if I'm done with that definition, I'll click the green check mark. And what will happen is it'll close Inventor and reopen the InventorCAM file with a copy of that solid. Okay, and you'll notice on the left menu there, some additional definitions we need to add. This is because we're now inside of the InventorCAM file. So first thing we choose is our post processor. And from this list, these are all the posts that I have in the folder that I assigned in video 1. Now you'll see on here, there's a couple of familiar names. There's a Haas, there's a Maltus. Your post will be in this folder. You'll receive it from our post department, place it in the proper folder, the one that you assigned in video 1, and then you'll find it in this list. So you just choose it on a part-by-part basis, or, like I mentioned in video 1, you can make it the default so that once you get to this window, it's automatically selected for you. For the purpose of this video, I'm just going to go with the Haas SS. Next is the coordinate system. So the coordinate system will be the setup, the offset on your machine, your actual machine. And we do that using these 4 bits of geometry over here. You choose one based off the geometry you have on screen. If I start from the bottom, you'll see it says by 3 points associative. Essentially, all that is asking you for is to choose points that represent the origin, a point in the X direction, a point in the Y direction. And as soon as you do that, there's my origin, there's my X, there's my Y. By the right-hand rule, X and Y gives you Z. Now, you would choose this particular option if your model, the solid you're working off of, is not a solid. Maybe you imported from Inventor a 2D geometry, a print, or something like that. You always open up the file from Inventor before you get into InventorCAM. And if the only thing you received was some sort of 2D piece of geometry, or maybe it is a solid, but there are no sharp edges, there are no flat faces, you're stuck using points. And that is associative as well. So if there was something changed on the original model, these 3 points will always represent the origin, the X and the Y. So your coordinate system will follow whatever changes are made. I'll skip up here to define because it works in a similar way. It's waiting for you to choose an origin, a line or a point in the X direction. So as soon as I chose that line, it made X axis parallel to that. And then a point in the Y direction gives us X and Y, and then Z. So similarly, this is if you had 2D print that was only straight lines, or a solid that doesn't have any flat faces, but it does have those straight line edges. If we go to select coordinate system, this is simply grabbing coordinate systems that existed in the Inventor file to begin with, that were imported with the file. You can choose those, and it automatically will set up a coordinate system based off of that coordinate system that came from Inventor. Normal to current view is mostly used for multi-axis milling, where you'll be looking at your part at a particular angle, and you'll think that this is a good coordinate system. This is a good index coordinate system. So you've already set up your origin, you set up your setup coordinate system, your setup offset, and this is simply just an angle to do a particular operation or a series of operations. It is a snapshot. So you click on capture current view, and you can see that the x-axis goes to the right side of the screen, the y-axis goes to the top of the screen, and then the positive z-axis comes out of the screen. That's because regardless of the offset, the z-axis is always the tool axis. So if you're doing multi-axis work, you want the z-axis to point in the direction you want the tool to come from. So if you're doing normal to current view, it's perfect because the view you're looking at is the angle that the tool would come from. It comes from out of the screen. If we go right to the top, this is the most commonly used option, and that is select face. This is if you have a nice solid with nice flat faces. What you're going to do is you're going to select the face to orient your z-axis. Again, your z-axis being your tool axis. Where the origin is placed is down here. Place coordinate system origin 2, and you have many options in this menu. Again, it's just a matter of where you want the origin to be relative to your part. So let's say I go with the top corner of the model box. So if I click on the top face of the part, the model box represents the outside edges of the part. So you can see all these edges here, these lines, are flush with the outside edges of the part. We get this imaginary corner here. We get points at each corner, each center of each edge, center of each face. And that's simply to help me to move the origin in the case that I couldn't really find where I wanted it in here. So let's say top corner model box, but I didn't want it to be that corner. I wanted it to be that corner. As soon as you choose your origin, no matter which one of these options you use, if you don't like where it is, it's not stuck. You can actually move it using all the other options down here. For instance, if I say pick origin, I'll move it to this point over here. If my X and Y are now in the wrong direction, I can do a flip around Z, and now it's in the proper location. So everything on screen is just to help you to place the origin. You place your offset, you place your origin relative to the part, rather than moving the part relative to a stuck origin. Now, I have just created Mac 1 position 1. The Mac number relates to the actual offset on the machine. So Mac 1 is the first offset. Mac 2 would be the second offset. So in the case of my Haas, that would be my G54. I have just set up my G54. Mac 2 would be G55, and so forth. If your machine accepts code where you have P1, WCS1, E1, whatever code represents your offsets, your G code will output that, but inside the software, it's called Mac 1. Position 1 is just 0 degrees off of that coordinate system. So if you're doing multi-axis work, you'll actually have position 2, 3, 4, all the way into infinity for the number of index positions you would take. So your Mac 1 position 1 is still the origin, everything at 0, 0, 0, 0, 0, 0, but Mac 1 position 2 could be at any angle you choose. Again, using any one of these other options. But the Mac 1 position 1 being set up, I'm just going to click the green check mark to accept that. And you can see your levels here. These are the levels we saw in video 1, where we were talking about the defaults of the coordinate system setup. So I have z equals 0 at the top face of my part. So that means my clearance level is 1 inch above that. Tool start level is 5 inches above that, and tool Z level is 10 inches above that. Because I used select face, it read from the solid that the lower level is negative 1.25, and that's probably just representing the height of this part. So the coordinate system manager shows me the offsets and the coordinates I've already made. If I wanted to put a coordinate system on the back side, I could easily do that, make a Mac 2. So all the different sides of the part can be represented in one CAM part file. You'll never actually have to leave this file to fully program your part. Let's go to stock. So the stock definition is the raw material you're going to make this part out of. And again, you have 5 options to choose from, again, based on the geometry you have in front of you. So the box definition is the simplest one to use. You can see that it could either be relative to the model. So if I just click on the solid, it puts a basic box shape around the part represented by those blue lines. And like we saw in video 1, I have some default settings here. It's adding 100 thou material on all the outside edges. That's fully under your control in the defaults, but it's also fully under control here as well. So if I wanted to maybe make it flush on all sides, I could go and make it flush by setting 0, 0, 0. And again, that's relative to the model. So now that is on all sides, there's no material. If I set it to absolute coordinates, using the coordinate system that I defined, I could give it the coordinates of each outer point to build my box. But if you actually know the definite size of your part, you can go to stock size. You can see that from my defaults, it put in 50 inches. That's most likely from the metric side. That's supposed to be 50 millimeters, but the idea is the same. It's basically giving the size of the box. If I set it to relative to the part, it should actually shrink it down to right on size. So if I needed a part, a block that is exactly the size of my part, it read it right here. So the box is 8 by 6 by 1.25. But if I need material on the outside edges, I can give it a bigger size. If I know the actual stock size of my part, I plug it in here. It's whatever you need. So let's say, for instance, we have a 10-inch by 10 by 2. So a little oversized because I want to show something specific here. So now that we have this box size, let's take a look at it from the top view. It actually centered it on all those sides. So it's centered in the X, centered in the Y, and centered in the Z as well. But let's say you don't want to be centered, especially in the Z. I don't plan on machining all that material. I probably want to put as much material on the bottom and only machine the top 10 thou. I can come over to offset by target, click on the positive Z, and just say, just leave 10 thou on the top. And it just shifts that definition so it moves all the material to the bottom, and that is my block defined. If I want to leave this blue sketch behind so I could use it in terms of geometries for my toolpath, I can just say add box to CAD model. And again, I get all the lines, center of each edge, center of each point, center of each face. So I'm just going to save that for now. So you can see that the sketch remained behind. But let's go back into it. We can take a look at the other 4 options. They're not as used as often, mainly because this one is pretty good. You can actually see that it's the box that you're about to machine, and it's your exact stock size. But let's say you didn't have the exact stock size. You had an oddball shape. Well, if you brought in a 3D model that represents that stock, you can use the 3D model option. So for instance, if I'm looking on screen and I had a 3D model, I could choose it. If I don't even actually know the size of my stock, I just need to get something on screen for my simulations, I can literally choose this part, and then when I do my simulations, I can just make sure that there's no gouge checking against the original part. But in this part file, I actually do have a solid. So let's go to CAD selection. We'll go to the model. And let's expand that. And you can see that I have a 3D model that represents my my aluminum billet. So 8.25, 6.25 by 1.375. So now that I've selected that, let's go back, click on resume. And now you can see that that 3D model that I selected is now set as my stock. So in my simulations, I now actually have the real size of stock that I'm machining. This also has the added benefit of being associative. So if I change this model in the original Inventor file, or even in this file here, all my toolpaths related to the stock will also be updated. Additional options are Extruded Boundary. So let's say I was machining a part that is an extrusion. In this case, let's say this one is an extrusion. I just need to grab the outside edge to tell InventorCAM that that is the extrusion that we're working with. So I'll just grab that edge there. I have my constant Z turned on, so it's looking for the entire sketch. And if we take a look at that in terms of what its simulation looks like, it actually is that extrusion right there. So I can just grab the outside edge and project it in the Z direction to the full size of the part. Cylinder is more useful in turning. It actually does the same thing as box. What you can do is you can tell it the size of your bar stock, the OD, the ID, and the length, and it places it around the part similar to what we saw on the box side, either relative to model or absolute coordinates. And then STL is if you're working between InventorCAM files. So if you had done some milling or some turning in one file, and you want to bring that machine stock into another InventorCAM file, you can do so. As soon as you click on STL, it asks you to browse for where that STL file is kept, and then you can set that up as the stock that you're going to machine in this particular InventorCAM file. And lastly is the target. So as we saw in video 1, I actually had it set to automatically select my target, but I'm just going to unselect it here to show you how this is done. So once you get into the target selection screen, you simply click on the target model, the solid that represents the final piece after all your operations. And you just click the green check mark. At minimum, all you need to do is define your post and your coordinate system. You just need to have something to reference to for all your geometries, and you actually need something to output code. But other than that, the stock and the target are not necessary to begin an InventorCAM file. The suggestion is that you do use them because then later you can do simulations. You can actually simulate what the toolpath is doing, the motions it's taking. You can actually see material being removed in some of the modes of simulation that we have in InventorCAM. But once you're done your definitions, just click your green check mark, and you're ready to add toolpaths to your part file. Any questions of this or anything else from SolidCAM, just give us a call at 1-866-975-1115, extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com. And stay tuned for the rest of the videos in this introductory series. Thanks for watching.